Good morning, children. Let us start group 17 elements. Yesterday we did half of the part. Today we will do preparation of chlorine. How will you prepare chlorine? Chlorine can be prepared by treating manganese dioxide with hydrochloric acid. We will have MnCl2 plus Cl2 plus H2O. What are we doing, children? Halogens topic, group 17 or 7th A, preparation of chlorine. Preparation of chlorine. The first reaction is manganese dioxide. When it is treated with the hydrochloric acid, we will have manganese chloride plus Cl2 plus H2O. Okay. Now next, potassium permanganate. Next method. Potassium permanganate on treating with 16 moles of HCl, we have KCl, manganese chloride, H2O and chlorine is liberated. Manufacture, children. How will you manufacture chlorine? Now, chlorine can be manufactured by Deccan's process by the oxidation of hydrogen chloride gas by atmospheric oxygen in presence of copper chloride as the catalyst. Here HCl is the manufacture. HCl, when it is treated with oxygen, will have chlorine along with the H2O. Now next properties. Chlorine is having the pungent smell. Colorless gas, the pungent smell. Physical properties we are doing. It is a greenish yellow gas with a pungent and suffocating odor. It is about 2 to 5 times heavier than air. Now chlorine reacts with a number of metals and non-metals to form halides. Chlorine reacts with the metal aluminium to form aluminum chloride. Chlorine also reacts with the phosphorus to form PCl3, phosphorus trichloride. Chlorine also reacts with the sulfur to form S2 disulfo-dichloride is formed. Now, this is an important reaction, children. When chlorine gas is passed through NaOH, cold and dilute solution, we have NaCl, NaOCl plus H2O. And the same chlorine, when it is treated with sodium hydroxide, hot and concentrated, we have NaCl, NaOCl2 plus Cl plus 3 moles of H2O. Okay, children, that closes the chlorine. Now, oxo acids of halogen. The oxo acid, chlorine reacts with hydrogen and oxygen to form oxo acids. The first member is HOClO, hypochlorous acid, HOClO2, HOBrO2, bromine, and HClO2, iodic acid, chloric acid, HOClO3, this is perchloric acid. And the structure of hypochlorous acid, HOCl, this is hypochlorous acid. Now, oxygen is having 6 electrons in the outermost orbit. 2 electrons are participated in the bond formation. Out of the 6 electrons, 2 electrons are participated. Now there will be 2 lone pair of electrons. Now chloric acid, children. Chlorine first reacts with oxygen. Oxygen in turn completes its octet state by reacting with hydrogen. Now, so chlorine also reacts with oxygen by the formation of double bond, and here also by the formation of double bond. This is chloric acid. Okay, children. Now, perchloric acid means this is perchloric acid. Okay. Cl is having same OH bond, and 3 lone pair of electrons are there. It donates 3 lone pair of electrons to 3 oxygen atoms. The compound is perchloric acid. Children, you have to practice the structures of these compounds. Now next children will do interhalogen compounds. What do you mean by interhalogen compounds? Two halogen atoms, they react in between to form interhalogen compounds. The general formula is X into X dash, X dash 3, comma, X dash 5, comma, X dash 7. Now, trichloro. Now, the examples of this compound is X dash 3, ClF3. Now, BrF3. Then followed by IF3, followed by ICl3. Okay, ICl3. Now the structure of this compound is children bent shape. What is the structure? Now let us start with the ClF3. Now Cl is having 7 electrons. Out of the 7 electrons, 3 electrons are given to the 3 fluorine atoms. And 2 lone pair of electrons are there. 3 plus 2 lone pair of electrons. So the structure which is formed is pyramidal structure. Or we can also say trigonal bipyramidal. Trigonal. When you consider only bond pair, it is T-shape, and when you consider bond pair and lone pair, it is trigonal bipyramidal. Now next, X dash X5. Here BrF5. Again, children, the structure Br is having 7 electrons. Out of the 7 electrons, 5 are given to the 5 fluorine atoms. 2 lone pair of electrons are there. It is square pyramidal. Square pyramidal. F here. It is called square pyramidal. Okay, children, clear? Now IF7 already we studied, children. Now this is BrF5. IF7 pentagonal bipyramidal. What is that? Pentagonal bipyramidal. F here. F. Okay, children, pentagonal bipyramidal structure. Now that closes, children, group 17. Now we have to do group 18 elements. Group 18 elements. Now children, group 18 elements. Children, group 18 elements. What are the elements? Helium, neon, argon, krypton, radon, and xenon and radon. Okay, children, what are the elements? Group 18. Helium, neon, argon, then followed by krypton, xenon and radon. Now these elements are having electronic configuration NS2, NP6. Octet state is completed. So they are having 2 electrons in the S block and 6 electrons in the P subshell. So they are having very high ionization enthalpy and they do not need electron gain. Enthalpy is almost 0. Why? Because since octet state is completed, they do not gain any electron or they do not lose any electron. Now physical properties. All the noble gases are monoatomic. They are colorless, odorless and tasteless. They are sparingly soluble in water. Now only xenon it can form the compounds. Xenon can form binary compounds XE electrons are there. Now these 6 electrons, they react in the form of the lone pair of the electron. So HCF2 is having 2 bond pair and 3 lone pair. So trigonal, by the